In this video, we're going to look at graphing a quadratic from standard form without a calculator. So we're going to do this by hand for, again, some of you who are being asked to do this by hand. So notice I did go ahead and write this quadratic in standard form. I did go ahead and write underneath it as well the quadratic standard form, so that you can see that the a value is this -2 value, the b value is -8, and the c value is 1. And right, so when we say a, b, or c, just keep in mind those are the values that we're talking about, the ones that are right above it, so you can see it matched up. Now, in order to start with this, I think the easiest way to start is to go ahead and just graph your axis of symmetry. And we can actually use this formula right here, x is equal to -b over 2 times a, to find the x value for the axis of symmetry. So I recommend that's where you start. So we're going to go ahead and we're going to put these values in place. So I'm going to put an equal sign, put my division symbol. Now notice it says -b, so I'm going to put a negative sign, but I'm going to put a set of parentheses for b. Now notice my b value is this -8 right here. So I'm going to take that b value and put it in my parentheses. So I'm going to write -8. And then it's over 2 times a, where our a value is this -2 that's in the very front. And so I'm going to take that a value and bring it over and put it in place for a. So notice right in our formula we do have a 2 that's in front of the a, so I'm going to put the 2 first. And then I'm going to put parentheses and put that a value of -2. And we do need to go ahead and work this out. Just remember that anytime you have a negative outside of a parenthesis, it means just to change the sign of the value that's on the inside. In other words, a negative times a negative is going to make this a +8. But if this was a +8, this negative on the outside would have made it a -8. So let me go ahead and write this down. This, when we distribute the negative sign, makes it +8. And then we have 2 times -2, and that's going to give me -4. And if I continue to work this out, -4 can go into 8, -2 times. So I'm going to go ahead and box that answer. So my x value for my axis of symmetry is -2. So for the axis of symmetry, if I want to write it, I'm just simply going to put x is equal to -2. And I think before going any further, I'm going to go ahead and I'm going to graph a line on -2. And remember, axis of symmetry run vertically up and down, and we do a dashed line. So I'm going to find my x value of -2, which this is my origin. You can see this orange and this pink line representing my y-axis and my x-axis. So from origin I go over 1, 2, and that's -2. So let me go ahead and draw my axis of symmetry real quick. Alright, so that is my axis of symmetry. I'm just going to label it AOS, or axis of symmetry. Now, since this axis of symmetry value is -2, I know part of my vertex. So I'm going to go ahead and put a set of ordered pair for the vertex, and I know that my x value for the vertex is that axis of symmetry's value. In other words, it is also -2. What I don't know is what the y is, so we got to find y. So to find y, I'm going to go ahead and I'm going to work it out by hand over here on the right. And I can find y because I know what x is. So we're just going to do some substitution. So I'm going to rewrite this equation that you see up here. So I have y is equal to -2x squared. So -2x squared minus 8x plus 1. Now we know that the x value of our vertex is -2. So what I'm going to go ahead and do is I'm going to substitute -2 in place of x, so we can figure out what the y value would be for that vertex. So let's rewrite this again. I'm going to put equals -2, but in place of the x, I am going to put parentheses, and we're going to put the x value of the vertex in there. So -2, and this is going to be squared minus 8, and once again, for the x, we're going to put parentheses, and I'm going to put -2 in there, and then I have plus 1. So now we just have some math to do, so let's go ahead and work this out. If I were to work this out further, this is really negative 2 times, I'll put a little dot, and since this is negative 2 squared, right, this is negative 2 times negative 2. And then I'm going to go ahead and multiply out. Negative 8 times negative 2 gives me a positive 16. And then we have plus 1. And I'm just working this out in small steps so you can see how I'm doing this. So if I multiply the negative 2 times the negative 2, that ends up giving me a positive 4. So I'm going to put a positive 4 in parentheses. And this 2 is still being multiplied to it, that negative 2. Bring it down. And notice I left it in parentheses after I multiplied them together because this 2 was being multiplied to it, right? So we don't want to forget to do that. And now I'm going to put these together. So I have a positive 16 and a positive 1. And if I put that together, it becomes positive 17. The next thing I'm going to do is I'm going to take this negative 2 and I'm going to multiply it to the positive 4. So that's going to give me negative 8. And then we have plus 17. So we're almost done. So negative 8 plus 17, if I combine those together, or you could look at it as 17 minus 8. That's going to leave me with a positive 9. So now I'm going to bring down my y, right? I wasn't writing it over and over again, but we knew it was there. And so I end up with y is equal to 9. So that is going to be the value of my vertex. So when x is negative 2, the y value is 9. I'm going to go ahead and write that right there. And let's go ahead and plot that point on here so we can see where our vertex is. So I'm going to go ahead. I'm going to go over 1, 2, right? There's our axis of symmetry. And then I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So all the way up here at the top. And I'm going to write vertex on there and put my ordered pair. Negative 2, 9. Now, we've got the vertex. Really, we just need one more point, right? If we find the y-intercept, like you saw in my last video, we can go ahead and plot that point. And then we can just use the axis of symmetry to plot a point that's on the opposite side of it, the opposite side of the y-intercept, in other words. And we can count out the same amount of spaces because we know that it's going to make a mirror image on both sides of the axis of symmetry. And then we can go ahead and draw our graph. So let's go ahead and do that. Let's find the y-intercept. So I'm gonna need some space for that. Since we're doing things by hand, it's taking up some space. So I'm gonna go ahead and work it out down here at the bottom. So I'm gonna move this up. Now keep in mind that when we are finding the y-intercept, the x value is always 0. So just like we had substitute the negative 2 in our equation, we're now going to substitute the 0 in our equation. So I'm going to do it right underneath here. So this is finding the y-intercept. So I'm going to put y-int. We're finding it. And we have y is equal to negative 2x squared minus 8x plus 1. And now that I have that, I'm going to rewrite it. So we got negative 2, but instead of an x, I know what x is. I want to find what y is when x is 0. So I'm going to put a 0 for x. And then minus 8. And in place of an x, I'm going to put a 0. And then plus 1. And notice I did forget to put the square, so put a square there. Now that's not going to really change anything, right? Let's face it, 0 squared is just going to be 0. So what we really have is we end up with negative 2 times 0 minus 8 times 0 plus 1. And anytime you multiply something to 0, it just becomes 0. Now I'm just doing this for grins, right? I'm showing you that when you multiply it, it becomes 0. And plus 1. So the only thing I have left is 1. So y is equal to 1. So mathematically, this is how we could show how we get the y value for the y-intercept, in case your teacher wants you to show your work. Now some of you may have looked at this equation and said, well, Mr. H, it said plus 1 at the end, and doesn't that value at the end raise or lower our parabola? And yes, it does. So you might have recognized that it was 1 just by looking at this end term here, your constant value. However, right, you can check it mathematically to make sure if you like, and that way too you can tell your teacher, hey, this is how I showed my work. Now what I'm going to do is we have another point. So let's go ahead and let's plot this point. Let's put 0, 1, our y-intercept. So I'm going to move this back down so we can see our graph. I'm going to go over here to 0, and then 1 is up 1. So notice when it says 0, right, we're right on the 0 mark for x, and then 1 for the y value. So right here I'm going to put 0, 1. I'm going to label it y-intercept. And now we have 2 points on the graph. All we need is a third point. Now what I'm going to do is use this axis of symmetry. I'm just going to follow it down until it lines up with the y-intercept. Notice my y-intercept is 2 units to the right of the axis of symmetry. So now I'm just going to do the opposite. And I'm going to go 2 units to the left of the axis of symmetry. 1, 2. And this will be my second point. Or I should say my third point. We have the vertex, we have the y-intercept, and now we have a third point. I'm going to find that location. So from 0 on the x-axis, I go over 1, 2, 3, 4. So my x value is going to be -4. And my y value is 1. So now I have 3 points. I noticed that some of your teachers wanted you to put those points into a table. So I'm going to go ahead and do that. I'm going to put right here, we have -4, 1. That's the last point we graphed. We then have our vertex, -2, 9. And we then have our y-intercept, 0, 1. So now I've also filled in a table with those values that we found. The last thing that I have to do is go ahead and graph this. And again, this is just a sketch. I'm not worried about trying to get the zeros perfect. I'm just drawing a line showing that it goes down. And this parabola is graphed. And I've shown my work how mathematically, without a calculator, I was able to go ahead and get my points.